Hello guys, welcome to this episode today. And this episode we're going to do a continuation where we left on different kind of database attacks. So in the previous episode we discussed about an inbound kind of an SQLi injection where we covered the error based, and we saw how we can use the errors to exploit a database by inputting some information, and when the database reverts some feedback with an error in it, we understand the object of the database, and so we can be able to emulate it or attack it. The second part is the union-based SQLi injection, where we combine two queries, we merge the results of two queries, and we understand how the database will be able to behave. For example, you had injected a payload that reverts an error, and the other one did not revert anything, so you can merge the two queries so to one payload and inject it to the payload to the application or rather. So we also covered the prevention strategies, but we did not go into deeper ways of how, or rather elaborate on how uh, we can prevent inbound kind of SQLi injection. It's very good to understand when you're going to attack, or you're going to do a simulation on a database. You need to understand what kind of database, I mean, what kind of an SQL injection are you going to target, or rather to search or to fetch or to hunt. If you're doing threat hunting for a database, so what kind of database type of SQL injection are going to hunt, and that trickle down to the script you're going to use, to the tools, or rather the material around that you need to be armed with. So in this case, to prevent against this kind this kind of an inbound SQLi injection, you need to use prepared statement and parameterized queries. So prepared statements are parameters, and parameterized queries are counter statements or counter payloads that your database has been subjected to a test, and you understand when you input such or when you send such kind of payload, it behaves in this manner. So you need to counter that behavior, or rather that feedback. Maybe it's an error. You need to counter that error by using a parameterized query. So that's the case. So the second case is sanitize user input to reject malicious character. Yeah, for example, for in any application you want to input, you're required for the username part, you input your name. So there's some punctuation mark that should be eliminated, that should not appear anywhere on the username, or the database should not accept that when some such kind of information is inputted that is unsanitized, that is unclean data is being trying to be injected or infiltrated into the database, and it can break or revert some information that an attack or a hacker can be able to grasp on that. Third is hide detailed error messages from users. Whenever an input has been initiated or injected or infiltrated to an application, the error should not revert to the user, or rather it should be sent to the database administrator, so that the back end, the database administrator can be able to understand. So this something was injected, and this what was tried to be injected, and this is how our database reacted. And by having a blind, or rather a blind uh, feed, a blind feedback, it will make the attacker need to escalate the kind of attack, or if they don't know, that's where they will stop. But it means at least some uh, vulnerability, or rather the security posture of the database has been tightened. So we finalize the prevention strategies for an inbound kind of an injection by implementing a web application firewall. So a web application firewall is a set of rules that is put in between our database and the whatever the the user end that is going to communicate. So what is going to be allowed into our system, and what is going to get out of our system. So in this case, for in our web application, what are we going to allow into our database, and what are we going to allow our database to get out when such kind of queries has been subjected to. So the second kind that we're going to go quick on is the out of band SQLi injection, or BSQLi. It occurs when the attacker cannot see immediate results like error or displayed data. So no immediate results is given out. But this one, we can retrieve information through alternative communication such as the DNS or HTTP request. So in this case, you don't have any information that the database has been hardened. In that case, the security posture of the database has been hardened. So you do not get the error, and for the inbound in the first case. So but you can use payloads from HTTP or the DNS. So that one will be covering later on. So when is the OBB SQLi used? This kind of an error based this when the error based and the union based are not effective, when these two kind of an inbound SQLi and are not working. So this is where we jump into this point. So when the database does not return immediate response but allows external interactions. Yes, the database gives an external interaction, but from maybe through the HTTP requests, that's for and also for the DNS. So you can eliminate from that end. So that's when you can use out of band. So let us jump into the inferential, the business of the day. So remember to subscribe, comment, share this to everyone that might think might benefit from this one. So for this inferential SQLi injection, or rather called blind SQLi injection, we are going to cover it in this episode. We're going to do a hands-on uh, lab on it. But for the inbound, we had done the hands-on in the previous episode. If you missed, you can go back. But this one I'm going to cover today, the inferential. But before that, I'm going to have just a small recap on the inbound before we move on. So for the inferential blind SQL injection, occurs when an attacker does not get direct output from the database, but infers information based on the application's behavior, such as the response time and the Boolean condition. So this type of attack occurs when attacker doesn't get output when some queries have been infiltrated to the database. We do not get the output because, as the name goes, it's blind. You see, but we can infer information based on the behavior. So maybe we'll put some queries. I'll be showing you how we put some queries to the application, maybe a character, a figure, a letter, a number, but it does not return anything. But you can study the behavior of the database. From the behavior, you can be able to enumerate it. For example, we can try to say that the database behaves sleeps after every 5 seconds. So from that point, we can able to understand after every 5 seconds we need to loop something. You can write a payload that can be able to loop that one after every 5 seconds. We behave this way. And the Boolean condition, this is the true, false, and true condition. So we understand it is behaving this way. So this is true. From true, we can able to invert and add some other characters and move on and escalate our attack. So when is it used? When is it applicable? When the application does not return database errors or queries. Yeah, the database is just blind, gives us nothing. As the name says, it is blind SQL injection, so we don't have anything. So how are we going to do this? Because the database does not give us information, um, as compared to the inbound, where it reverts some information to give the database, spits out some data, and we can able to net from that point. We can able to inject more. So in this case, when the attacker needs to guess database bit by bit, and that's why I said here we need to understand the sequence, the behavior. That's the time of the Boolean condition. So without further ado, let us go and dive in. Let us go and have a hands-on experience. But as I said before, we're going to do a recap, quick recap, hands-on recap on the inbound SQLi injection. So let's dive into the lab of the day, and thank you. Remember to subscribe. We need to understand what we're going to use, what is the tool that we're going to use in this. So the first thing is metasploitable tool. I had highlighted on how to install, to download, and install just the same way I had shown in one of the tutorials how to install Kali Linux, the same thing. But during the previous episode I had indicated on how you can download Metasploit 2 from the SourceForge or from the Rapid7 site, of course. So this is the machine that we are going to attack. So let us log in first before we move to the attacking machine. This is the victim. Exploitable 2 is going to be the victim that we're going to attack. So to log in, the username is msfadmin. The same goes to the password is msfadmin, and we are here. So let me clear that. So we are already logged into our machine, and the next machine that we are going to deal with is the Kali Linux. Let me check out, where is it? So for Kali will be used to, come on, Kali will be used to attack this machine. Is it here? So this is our machine, this is our Kali Linux. So this is our Kali Linux, and first thing first, we want to check the internet connectivity in this Kali Linux. If we can connect to any external endpoint device, that may be a server, any device, if it can communicate to the external internet. So for this case, we to the external devices, I mean to the internet, that is. So in this case, I'm going to use Google. So I'm going to give it 4 ping. I'm going to send 4 IMC and or rather ping messages to the Google server. So in this case, I'll say ping is 4 counts, and we say, let us write it here, google.com. Let me expand this one. So yeah, we're having some connectivity. So as you can see, we have 4 packets transmitted, 4 received, we have no loss. But you can also use let me show you this another. You can get someone using this one, or somewhere you use this one. This is also a Google server 8.8. So if you check like that, it means also the DNS is working, because this is just a raw address of this Google IP of this Google address. So this is just a raw address. So the same thing, we have connectivity, that's good. So we want to go to our Metasploitable and also do the same and check if you have connectivity, because an attack is only capable if you are connected to the internet. So let us try this, the same thing. Good. So what do we have here? So before we go any further, please remember to subscribe, share, comment, and let me have your feedback. Let me know what you are thinking. So let us connect and try to ping this onto the Google server. Ping. Let us give it even 3 counts. So as I said, we can use this one. Hope you are getting that. Yeah. So we have 3 transmitted, the same thing. Our connectivity is there. Let us check if our DNS is working, but you're not much concerned with the DNS at this moment. So everything is just working fine. That's voila. Now we want to check the IP address of this device. So our Metasploitable, our IP address is 10.0.2.7, and we want to use that to attack that machine, because we have that IP address. We have so many ways we can use to do a reconnaissance of a device or an application in that case. But in this case, since we have access to our device directly here, we can just go directly. But next time, or in another tutorial, I'll show you how to enumerate by using nmap, and how you can do a a sweep on our local area network to understand the kind of devices are there and the operating system and everything. So in these cases, we have access to our IP address or our device. We know the IP address. Let us just dive in for the sake of time and to save that. So first thing we'll do nmap, and we check on the operating system and the version, and let us input our IP address over here. So this is the IP address of our Metasploitable2. So because we're going to attack that using this machine, and this by default nmap will scan the first 1000 ports, and this is a scan report for this device, this target device, and that's our Metasploitable2. And of course, if you want to attack any machine, this is the first thing you need to reconnaissance. So you need to know the vulnerabilities of that device. So in this case, we want to understand the vulnerabilities or the weaknesses. So it scanned the first 1000 ports, as I said, by default. So the 9 out of 1977 ports are closed, as you can see here. The rest over here, 123, are open. Yeah, so these ones are weaknesses. This is what we call vulnerabilities on a system, and you'll never get something like this on a normal production environment. These are weakness, these are vulnerability, and this machine is made, or rather the Metasploitable2 is made like this for a reason, by default, so that you can able to learn, punch our skills, our tools, and practice in a safe environment, so we can practice using this. So in this case, we have so many ways and so many vulnerabilities that you can exploit that machine, but we are only interested in this tutorial for database attacks. So we have two databases here that are open. We have two databases here that are open, and the first one is MySQL, and the second one is the PostgreSQL. And the good thing, it tells us the version, as I told you, this is the versions. PostgreDB has this version. You can just copy this one and go to your favorite browser and check the kind of vulnerabilities or any common vulnerability and that has been reported on this kind of version. The same thing happens to this. So since we have a connection to we are connected to that device, and we have seen whatever is going on, we want to go and enumerate directly the database. So we'll go to our browser. From our browser, we want to input the IP address as 10.0.2.7. So this is the IP address of the Metasploitable2 machine. You all know this IP address, we have checked together, and as you see, it tells you this Metasploitable2. By default, by we getting this information, it means we can connect. Our machine can communicate with the Metasploitable2 machine. You can also try and ping, but up to this point, you should understand that it can. You see, it communicates. So as I said, maybe you have the IP address, or you have managed to infiltrate the local area network of your target device. Now here we are. After finding the vulnerability, that's the reconnaissance. Now we want to exploit it. So you click on DVWA. So this is the damn vulnerable web. This is the site, or the dashboard, or the interface that you can use to enumerate this database. So it tells you the username and the password. So the username and the password are all here at the bottom. They are you have been given default, but next time we'll show you how to emulate and attack, get the password and the username without even checking here, because as you can see here, you've been told this is an hint. If you fail, you can use that, but in this case, you're not here to do that. You want to do another way. So the password is admin, the username is admin, and the password is password as well. The next tutorial will show you how to crack that without even checking there. So when we input that, this is our dashboard. So this is what we get as the interface. So the first thing, we need to check our security posture. So all these types of attack can be tried over here, can be worked over here. But before you start, let us go to our DV security at the bottom left hand side. Click on DV security, change this to low so that we can start by low level attacks. So we call them the low hanging fruits, the vulnerability that we can easily grab, because we need those low hanging fruits so that you can be able to curate high comprehensive payloads that can go and achieve whatever you want in a snapshot. So after doing that, if you submit it, to tell you the security is low, currently low. So I want to go and do a very quick recap on this kind of SQL injection, that is the inbound, before we dive into the blind or inferential. So we're going to do the inbound very fast, but I had covered in the previous episode. I want to show you something. So in this case, let us try and input one, enumerate this data. As input one, it tells you the ID is equals to 1, and of course here on our browser on top here it tells you the ID is equals to 1, and it submitted that. Whenever you say IDs with ID is 1, the first name is admin and the username is admin. You can try the same, even let us try 5. We have Bob, we have something, let us try 9. You have nothing. So you can go like that. Let us try up to 6, because it means we have up to 6 column of 5. Yeah, so you see this one, it gives you a feedback. It tells you ID 5, it's Bob and the Smith. So maybe have 5 columns. So because if you say 6, it does not revert anything. So you can study the behavior of the database using such kind of low hanging payloads. Like just input the figures, and now we know we have 5 columns, or yeah. So if you have if we have that, so let us try and say open that quotation, single quotation, and say or if 1 is equals to 1. Let us comment this out. So we are trying to query the database because 1, it is equals to 1, and we know 1 is admin. So we are trying to check what comes before that. What comes before that? Do we have anything that we can equate to that? So 1 is equals to 1, and it tells you to spit out all the information. Don't need to go further. Look here. So if 1 is equals to 1, admin, go down. That's the first name. Username is Brown. So it's 1, 2, 3, 4, 5. That's what I've been trying to do. So it tells you 1 is equals to 1, and we comment that out. So this hash is used to comment out. Maybe you're trying to emulate a weak database. If you leave it without that hash, you can try to hash like this. Sometimes it refuses. Yeah, it will refuse. Maybe it's you see, you are MySQL version. So this version, MySQL server version for the right does not use. So you see this kind of MySQL does not. It tells it's a MySQL, and you know SQL do not accept that. That's why we use this one. But whenever if this one refuses to hash out, you can use 2 tags like this, or switches, or dash. So for this case, we know that one has accepted. So let us try something else. It has printed out. So let us use and equate this one to 2. Of course, that is false. That one is false. 1, you can never equate 1 to 2. 1 is not equal to 2 in logical sense. So we are trying to play around with this database. If 1 is equals to 1, and it can spit this kind of information, what if we try to manipulate 1, we equate it to 2, and if it's possible, it can throw us to another level of column or some information, and from that point you can able to understand the structure of the database. But in literal sense, this one is not workable, and as you can see, it has refused. nothing has been reverted. Now let us try a union based attack. Union select. So the first one has been we have been working and get an error. The first one gave us an error, and that there it also reverted some information that we have saw here. So we let us do the union because we are still under inbound injection. So select, want to get the columns. So the column name, so null from information schema. Columns where table, you have information schema and the table, you want to get some column what it can split, where table, this is a schema, we create the database, say hash. Let us check out this one. So we have A over here, and before that I think I could have shown you something. When you say A, what will it say? It will give you nothing. So let us input our, so we're trying to, because A does not give us something and we know we have some column, there's some name and some table, we are using a union to combine all these two and see if it will give us something. We try to confuse the database because yes, A does not give us something, but we know it has some column and some table and some name. So we are trying to connect, to join these two things using a union, these two inputs, or rather query, or rather payload, using union statement. When you say submit, and voila, you can see some information over here. You can see some information over here. Then we have a column for comment, for name, for user ID, first name, last name, user, password, and avatar. So we have a couple of databases information that we have splitted over here, and you can imagine maybe this is a normal shopping site or a shopping mall. You go there, you input some information to their database, like your credit card information, credit card number, yeah, so that it can be awarded points, the loyalty points. You can have a column for the same, you can have a column for email, maybe they take hold of or grasp or get your phone number. So you can do that, and to any organization, any business that has a database, and pull out some information like this one. So let us check on the passwords on the, because we have seen there's an here password, there's a column of password. Let us try and do that using union. Union, select this thing. Yeah, I presume you're seeing that. So union select the users, so the password, and from users, comment that out. As you see, from our users column, we have admin, and the admin, this is the password, and but it is in a hashed format. But you can show you later on how to, in the next episode or later on, I'll show you how you can change this one into a plain text. Because if your password, for example, is password like this, when you put that password and say submit or enter, whichever the platform you are. The database in that on the end does not store your password in plain text. It encrypts the database into a ciphertext like this one. So we can change this one and use this username and the password and you and login. The same thing to Gordon B, the same to 137 Pablo. You have Smithy and so on and so forth. So to this point, I think we have exhausted much further on inbound kind of an attack, because we also covered the same on the previous episode. So here we're just here to do some recap, and so let us dive in over here. Make sure the DVS security is still low. Yeah, if you submit it should be low over here, because if it is high you import certain most of the input will refuse, because they need to be curated. If they are high, you need to pick those small details, those low level details, so that you can input them. So in this case, just low. Good. So let us go back, and we want to do something to extract here. So when you say something like A does not give a feedback, and you say till anything, just input any figure, you don't get anything, because the database has been created in a manner that it cannot work. They know, the database administrator knows this kind of inbound SQLi injection exists, and they have hardened the database so that it can refuse our inputs, and they call it the unsanitized inputs. So in this case we're going to okay, let us input like even y, any digit. So when you come over here to our browser, to our link, it tells you our id is equals to y, and when you submit it gives you nothing, right? So let us take this browser. So we go back to our, what is it called, our terminal. Yeah, so for our terminal we want to use this guy called an SQLmap. An SQLmap, it's an automated machine tool that is used to attack machines, and it's quite handy when you want to do attacks on databases. So when you just say SQLmap, it will give you a revert error to tell you what's missing. Yeah, you can go check on that. You can do a man on SQLmap, but I'm not here to do that today. It does not matter. SQLmap. I've done wrong. SQLmap. Yeah, it has a man. So from this you can learn a lot of things, and maybe you cover it later on, but not right now. You want to use it as a Swiss, a weapon, knife. You want to attack our database. So let's say SQLmap once more. Something missed out. So if it tells you what's missing, mandatory options, so you need to have at least this, so that it can have. So let us use U. So U is for the URL, and as you've seen, you've copied the URL from our browser over there. So you open a quotation mark like this and paste the browser. And as I told you earlier, during in SQL programming language, hash is used to comment out. So we want to remove this hash at the end of submit over there, and close this URL. So we'll go back to our browser again to get some cookie bit, but before that let us prepare cookie. Let us equate this one to here. So leave it like that. Indicate cookies, switch cookie equals open, like that. Leave it like that. Let us go to our browser. So we want to take cookies. So from cookies, we can go to this, we can toggle over there. More tools, yeah, I believe. Yeah, more tools, and you get web tools over here. But you can also do Control Shift I, and it will direct you over here there just one time. So this over here, you make sure you toggle and click on storage, because sometimes you can get it to it is on accessibility. Make sure it is on storage, because we want the cookie that we sent Y, and we want to create to steal that session. So click that one over here. You see cookies over here. Click the first one, and at the end, click that one. Right click and copy it. Easy peasy. Come to your terminal, paste it. So we are not going to close this one because we have two cookies. So you just want to equate. You're going to equate like that. You're not going to close. Semicolon. You put a semicolon over here. Then go back. As you can see, you have two cookies. Maybe you have not here. I've not indicated this one is the first one, this one is the second one. So again, click the second one, the end, copy. Come back to your browser, to your terminal I mean, paste it. So let us remove first those closing quotation and equate that on to low. The security is equals to low, and yeah, we indicated low. Remember when we were doing our security, DVW security issues, used low. So this is the cookie, this is the session, this is what has been happening. And when we sent Y, when we inputted Y here, you can see this Y. You can just use any figure, any something. But during our session, when we inputted I to our application to log in, this is the cookie that was generated, and the security was low. So we want to use the base of the database. So the base, current database. We want to know the current database. B. I also want to know the current user. Very crucial. You want to understand, if you enumerate this database, what is the name of the database, and what is the name of the not the name, what is the level. Are you getting there as a root user or an administrator if you're from the Windows side? So if are you getting there just a normal user, administrator, root user, or what? So that's very important, because the moment you realize you can infiltrate a database as a root user, it means you can able to do anything like a database manager, like a DBMS. So that's it for now. Let us click enter. For the time base, as I told you, in a blind or inferential, you don't get the feedback directly, but you can run the payload and understand what it behaves after a certain period of time. So in this case, MySQL, this version, time-based, we have this query to sleep, and it is for sleeping. It used this payload. Actually, the goodness of using that tool, SQLmap, it used this payload, and it tried to run this query to understand how the database behave, how often or the sequence of it to become on and sleep, what is the pattern. So we got after every 5 seconds it sleeps. After every 5 seconds it sleeps. So from that point you can able to enumerate, understand before 5 seconds we need to be done with this. We have already done or exploited one of the features. Next, we have a union query that was run here that found two columns. This is the payload, and it has told us the backend database management system. It is MySQL. It's fetching for Banner, and it found a web server operating system. So this is the web server operating system, Linux, Ubuntu. This is the version 8.04. Web application technology, you have PHP and Apache. Back-end operating system, we have Ubuntu. Back-end database management system, we have MySQL, and this is the version, and that's the banner. So this is the banner fetching current user. So here we have, as a current user, we are root. So if you are a root, you can do anything with database. You can add information, you can spit information, you can delete everything. So you can imagine if this is an organization and you can able to immigrate and getting as a root user, it means you can do anything and everything like a database manager. So if it's an organization, you can add malicious or bogus content or delete, or you can just do anything that you think it can be done to a database, because a database is a jewel of information or data to any organization. So current database name, it's a DVWA. We have been told that's the name. So, and more information has been logged in this location. You can have more information here, but before we go there, I want us to get as a lot of information as possible, so that whenever you start enumerating, or whenever you want to curate a comprehensive payload on a higher security posture, you have a lot of information. So what are you going to do next? The next thing you're going to do, you want to check the name of the how many database, name of the database, the DBS. We want to check how many databases are available within the system. How many are there? As you can see, available databases, we have 7. This is the first one that we have already been told. And we have this information schema, metasploitable. We have a couple. So we have 7 databases. So you can, from that point, you can know where to move and what to do. So let us try another thing. Still, it will log our information over here, and just use the upper arrow key to get back the previous query. Don't need to type it all. So delete the final part. I believe you are together to this point. Don't forget to subscribe. Don't forget to subscribe, please. Okay, subscribe to the channel and make the channel grow. So let us go to to this DVWA. So this is the database that we are pointing on. We want to check if, the tables that are available within that database. So you pointed like that. So the Ds for the database, as you can see, you have 2 tables, guest book and users, and so those are the tables that we have there currently. Let us do something else. Under that table, under that database, let us go to table, let us go to users, let us go to this use, because most of the valuable information is stored in the users. Just a hint, but it depends. Maybe the database administrator has changed to guest book or something else fun, but most of juicy information you get them on the users. So let us go there and check if there's something good there, and want to see the columns present. And as you can see, under users, so this is the database table columns. So under columns we have 6 columns for user, avatar, first name, last word, and user ID. So as you can see, we have a lot of information. You can get that from there, but it is still, it has been logged here. We'll go check there. Let me go try and dump. Let me go try dump this one. We go dump all this information. Yeah, it is dumping. Guys, don't forget to subscribe, comment, share. Comment, share, subscribe. as it keeps on logging. Okay, what is it saying? So do you want to store hashes on a temporary file or for eventual further processing with other tools? Let us say yes. Do you want to crack them via a directory based tab? No, we don't want to do that for this moment, but yeah, that's what you can get to this point. Subscribe, comment, share, man. Channel Injasi from don't forget to subscribe, comment, and share. So at this point, I believe we have some information that you want to go back and check there. So this is what we have. For the first user is the username, avatar, password, and you can just crack this and check this one and use this password and the user and login any account. This is the first, the last name, this is the first name. We have all these accounts here with the user here and the password here. I'll show you how to change this as hypertext to plain text and login, because you can't use user admin and input this one copy paste directly. And no, as I told you, the database does not store directly passwords in plain text. No, you need to change them to from a hashed format to a plain text. So now that we have been told which data logged to, all the information has been logged here and the dump has been logged to this directory over here. So we want to know our current working directory, say pd. There's a present working directory and we are currently here up to home. So you want to move to this point, local share output. Just copy that, cd. In the previous episode I indicated how you can create a file, move to a directory. How you just simply navigate directories and make files, delete files, and do all those things, basic things to the Linux machines. So if you say cd, copy that and paste it over to there, say enter. As you can see, it has changed. And again, if you ask it present working directory, it will tell you. So now we are here. So let me clear. We need to clear this. So say ls to list whatever is the content. And here we have a dump file that we told it to dump. We have a log. This is where all the whatever we have been doing has been recorded. And that's why I told you SQLmap is kind of loud, because if you're doing this to a machine that has or an application or a website or any device that has a log correlator, or they can collect logs, they'll still find what something fishy was going on, and they will know it was SQLmap because it has known scripts. So we have session, tell you the session, the target will tell you the payload that has been used, that we injected to this file. So let us check, let us do cut and dump it. Dump just to check what is there. So dump is saying it's a directory. Sorry, change again. It has okay. When you list, you say they say this dvwa. I don't know if it's a directory cd dvwa. Let us list it. Users CVS. So let us clear this first. ls. So cat users dot csv. Here's the information. Now if you can use nano, the same users dot csv. Still, so the user id, but for a dump is used if you want to use this information to with another tool. That's why you can cannot be opened well here, unlike before where we saw everything was indicated well, like the password. You see the arrangement, it's not good. So the user, this is the user, the first user, user ID. Let us go step by step. User ID, this is the user ID. User, this is the user. Avatar, this link over here is the avatar up to this point. Password, this is the password up to this point. And as you can see, these are JPG. These are it's a picture actually. So the password, you have a password here. The last name is admin, the first name is admin, and so on. So we can use this one open to another tool, but in this case we have information that we need. Let us get back. So we have already dumped some information. So what next? Let us do a CD, and want to move 2 steps behind because we are in the dump. We are in DVW and dump. We want to move up to this point, so 2 steps behind. So we say PDW, let us list. So we have dump here. Let us clear this. So let us cut. Is it log? Yeah. As you can see, the log, it will give us even information that is friendly to view. See, this is the whole information. We have a lot of information over here. Everything that we have been working on, every step here you can see from this point. SQLmap identify the full injection with 141 HTTP. These are payloads. These are two payloads that were used by SQL. We found that one. We find the union information about the database, kind of injections, and the payload as well. It gives you the payload. And this is the payload that it used. You remember our T, our input T, our ID was equals to T. So it tells you everything that happened because it's a log. It's a log for the information. Server, the technology, the application technology. So you have the application technology you can use to form a comprehensive payload that matter. Parameter, you move the type available databases. What next? And so forth. Tables. What else? Columns. 6 columns. Remember to subscribe, share. Till next time, take care. Bye.